Hi, Lisa Pierce here, Executive Editor of Packaging Digest, with a opportunity to talk with Carol Franklin, who is the Director of Standards Development for Robotics at the Association for Advancing Automation, also known as A3. They just announced an upgrade to the robotics safety standard here in the US, and I wanted to get a few more details about it. Carol, thank you for joining us.
Well, thank you, Lisa. I appreciate the opportunity.
So we have this new standard, which was revised. Why did we need a revised standard, and why now?
Well, basically, we're talking about the R1506, which has just been published in the United States in the 2025 edition. So the official code is ANSI/A3 R15.06-2025. So that's the
A mouthful.
R1506. Yes, R1506 for short. And R1506 of 2025 is the first new edition of R1506 since 2012. So it's been 13 years since we've issued a new edition of R1506, and really the reason why now is because it's more than time. So
lots happened in the last decade with robotics.
Indeed, a lot has. And so basically the title of this standard is American National Standard for Industrial Robot Safety, and it essentially incorporates the ISO 10218 Part 1 that was recently published in 2025 earlier, and 10218 Part 2. So both the 10218 Part 1 and Part 2 were published January 30th, 2025. And so since then, the R15 committee has gone ahead and approved a national adoption, taken the 10218 content and turned it into a US standard R1506. And so the R1506 of 2025 is technically fully consistent with 10218 of 2025. And so what this does is this makes the R1506, the American national standard, consistent with 10218 and all other 10218 national adoptions worldwide. And so this series of standards has been a really big success story for the benefits of doing the work first in the international sphere. So in other words, working on the content in the standard in ISO, and then bringing back to each country and nationally adopting, or whatever that country's particular way of bringing that content in. And so, for example, in Canada, they nationally adopted as well. And the Canadian edition is Z434. And actually, our Canadian colleagues are right in the middle of completing their national adoption as well. And I believe the last time I heard from them, their national adoption will likely be published in about 6 months from now. And so what we're going to have across all of North America is that R1506 and Z434 are going to be consistent with each other and with 10218. And so we're going to have consistency across North American major markets. And that's really a huge benefit for the industry. And so
benefit, I can see. I know that there have been, in other instances, harmonization with international standards. We also cover medical packaging and the medical device industry, and there's been a lot of harmonization on that front as well. Could I ask though? This is a safety standard, and I know that there has been a huge increase in the use of robots in industrial applications, factory applications, including quite a bit in the packaging industry. And I did a little bit of research online, but the research was not clear whether or not there were an increase in the numbers of safety incidences, accidents, and it just kind of goes along that if there's more robots out there, that it would make sense that there would be more accidents. But can you talk about that just a little bit?
Yeah, the challenge there is that the data actually doesn't really exist very conveniently, and I think you probably found that when you did your research.
Yes.
Essentially, the best way, and actually, we in A3 have an official alliance with OSHA. It's a three-way alliance with OSHA, NIOSH, and A3, and so, we're highly supportive of data because we obviously are we're a high tech trade association, and we're big believers in digitalization and the value of data, and also data driven decision making. So I've actually looked into this question a couple of times just for our own information, and the challenge is that the data are not really captured in a way in surveillance of the marketplace in a way that makes it easy to do a robust understanding of trend lines. And so the best way that I've found, for example, is to look at a database that OSHA has and do a keyword search. And so in doing that, I found that approximately on average, taking the total number of incidents and the total number of years we were looking at, the average is approximately 1 fatality per year associated with the word robot. And that's over the past 20-ish years or so. And that was consistent when I did it across a couple of different time spans. And I would say, I would feel fairly confident in saying that's about the rate. And but it's difficult to say, because if you do the keyword search and it's based on a textual description of what the incident was. And so the word robot isn't always used in a precise way. And also, sometimes it's used in the text in a way that has nothing to do with the actual incident. So for example, the last time I did this, and I think it was a couple years ago, but the last time I did this kind of analysis and tried to do this count, one of the top listed incidents said something like, the worker was standing beside the robot when he interacted with the press, and it was actually the press or whatever the other machine was. It was another machine that actually did the injury, and the word robot was only to tell where in the facility he was located. The actual robot itself wasn't the source of the injury. And so the data are very messy in that regard. They're a little bit nebulous, and they're also not totally precise. So unfortunately, in the US, we don't have, we have some limitations in the kind of analysis we can do on this. But now, taking those limitations into account, I would say that no, we have not seen an increase in the rate of injuries. And I have heard of a study that was done in Germany, and unfortunately, it's not a publicly available study. So I've just heard this data, and I haven't been able to put my hands on the actual study. But basically, they did a study that said the number of robots used in that market increased sixfold over, let's say, 10 years. And at the same time, the number of injuries did not increase sixfold. It stayed the same, which tells me that the incident per robot, the incident rate is actually lower than it was 10 years ago. But again, this is, I have not actually seen the actual study myself, so I can't judge for myself. But that data doesn't surprise me, because we find that robots and other industrial automation are typically deployed in tasks that are dirty, dangerous, and dull. And so because we're actually removing a human from a dangerous task, robots are actually a net plus for safety. And we strongly believe that, and we believe that that actually the robots, again, with the limitations of the data, but taking those limitations into account, we believe that the use of robots has been a net plus for safety in industry, and that the robotics industry as a whole has had a very good safety record, especially when you compare it to some other types of industrial machinery. So remember, these robots are industrial machines, and they have to be treated as such when you're having people work around them.
Right. Carol, one of the reasons for a safety standard, though, is to prevent accidents, incidences. So that's good. I would like to ask you to itemize maybe a couple of what you would see as the key changes to this revised standard. But I have what I think might be a quick question right before that. as robots are industrial machines, I'm assuming that lockout tagout applies to them in some way. Is that correct?
It does, yes. Lockout
Okay,
tagout
excellent.
does currently apply. And
Okay,
again, in the US, one of the reasons why our data are a little bit amorphous is because robots are included in the broader category of industrial machinery. And so the codes that are applied to describe a given incident, again, it's all about industrial machinery. It doesn't parse out robots except textually. And so we've already
okay.
talked about those limitations. But yes, so lockout tagout does apply, and be aware of that. So,
Okay, great. So getting into the revisions, what would you say
mhm.
are some of the key changes?
What's different in 13 years is that in the 2011, we had just been starting to see the beginnings of collaborative robotics. And so in the 2011 edition, we knew that was coming, but we also, when you're working on these standards, at some point you have to get to the end. You have to say, all right, there's a lot of new great technology out there, but we have to finish this document. And so whatever this new thing is, it's going to have to come in the next update or possibly a different document like a technical specification. And so in 2011, the committee said, okay, we're cutting it off. We got to publish this thing. And we know collaborative robotics is coming, but we don't know enough yet to be able to say what the safety requirements are. So we're going to say in 2011, all we're going to say is it can be done, but we're not going to be able
Okay,
to say how to do it. And so the
great.
next step at that time was to develop what came to be known as TS 15066, or that's in the ISO world. So 15066 is a technical specification, which in the ISO world is sort of it's kind of a, it has requirements, so it is normative in the same way that a standard is, but it's a technical specification and not a full standard. And the reason for that is typically because it's in an area of technology that is undergoing rapid change, and so it's not considered ready quite for a full standard. However, it did
Okay,
have normative requirements, and so we nationally adopted that, as in the U.S. the technical report, or TR 606, R15.606. And so taken together, the 2012 edition of R1506 and the 2016 edition of TR 606, the two of them together gave you what you needed to implement a collaborative robot system safely. And
okay,
so now, one of the key changes in the 2025 editions is that we've taken that content that had been in a separate document. So it had been in the ISO framework, it was 15066. In the US framework, it was TR 606. We took that content and we baked it into the whole main standard. And so the entire standard was rewritten with the assumption that collaborative robot safety, collaborative robot applications, that they are a thing. And so that's a really big change, is that the safety requirements to make a collaborative application safe are baked into the main standard. And you no longer have to buy a separate document to be
excellent.
able to create a safe collaborative application. And
Okay,
also,
that is
yeah,
a
go
big
ahead.
deal for
Yeah.
packaging because a lot of the uh, new applications for robotics today are using cobots more so, cobots and mobile robots. Industrial, the full size robots are still uh, well in use, but it seems like when people are thinking robotics today, they're looking at cobots more so than in the past.
That's probably true. Although I would say that our another thing that A3 does is our market intelligence department puts together the sales figures, and I would say that the vast majority of systems sold today are still what we call
Yes.
conventional industrial
Yep.
robots. But it's also, I wanted to point out that what people call collaborative robots are actually in the standards world, and according to the standard that we're talking about, those are actually typically what's known as power and force limited, or PFL robots. And actually, even though the sort of marketing term cobot or collaborative robot is taken on a life of its own. All those robots are a type of industrial robot. They're not an alternative to an industrial robot. So there's conventional industrial robots that require safeguarding, but there's also the collaborative systems also require safeguarding. It's just that they're not necessarily fences. They're safeguarding using sensors. So it's safeguarding using, in the case of power and force limiting, the robot itself is equipped with sensors and control limiters to limit the amount of power and force that it can exert. And also if it detects an obstacle, such as a human arm or whatever, it stops moving. So that itself, that capability itself could be thought of as a kind of safeguard. It's just not a fence. And so and these machines actually, the classic example is one of which, well, the power and force limited robot itself may have limitations to the amount of power and force it can exert. Itself, it may have rounded edges and rounded corners and softer compliant materials so that if it strikes you, it's less likely to harm you. And those are all good things, but it can still hurt you if it's integrated with an improper end effector or workpiece. And so the classic example is a power and force limiter, or supposedly so-called cobot arm with a knife on the end. It could hurt you, okay? And so the standards community feels very strongly that there's really no such thing as a collaborative robot. The only thing that can appropriately be described as collaborative is the robot application, because the application takes into account the end effector and the workpiece, as well as any ancillary equipment that enables it to do its work. And that whole system together, taking into account the workpiece and the end effector and any ancillary equipment, is the thing that could appropriately be called collaborative. And that's what we're calling in the 2025 standard. That whole system and all of those parts of it are what we're calling an application, industrial robot application. I believe that we do not have the term collaborative robot anywhere in the entire document, but we do have collaborative applications, and that's why. How to handle that whole topic is baked in to the main standard now, and you no longer have to buy a separate document to do that.
Okay. And I understand there's also new content in there on the end effectors, as you were mentioning, as well as the loading and unloading procedures.
Yeah. In the intervening years between 2011 and when we started the update in 2017, the ISO world published 2 technical reports, as well as TS 15066. And the 2 technical reports, one was about end effectors, so it was safety design for end effectors, and the other was about manual load and unload stations. And so those 2 technical reports, again, like TS 15066, have been kind of rolled into the main standard. And so all of that content is actually those source documents were added as annexes, and then also they were updated. So so not only were they added in, but the content itself was further scrutinized and updated by the committee. So all of that information is baked in now. Say the other thing that's a kind of a really big change is the use and guidance about safety functions. So in the 2011, there were a few safety functions that were talked about in part 1 for the robot and part 2 for the robot system. And the amount of guidance we were able to give at that time was somewhat limited. So in one of the big priorities that we had for the update for the 2025 edition was to give updated, more detailed, and clarity about safety functions. And so we actually have a much greater list of safety functions now that we can describe, and whose requirements are stated now in the standard. We're really happy actually with how we were able to describe and improve how we describe the requirements for safety functions.
I also noticed that cybersecurity is addressed in the standard, the revised standard. So how does cybersecurity connect with robot safety?
Yeah, and again, this is something that's changed a lot since the last edition. So in the 2011 edition of 10.2.18, 2012 edition of R1506, the cybersecurity wasn't really a huge concern because these systems were essentially standalone. So a technician would have to be present on the floor of the facility and walk in a thumb drive or some other means of changing things. Since then, though, a lot has changed, and everything, we've got the industrial Internet of Things, and essentially we've got everything connected. Obviously, that creates vulnerabilities, and for the most part, cybersecurity is a concern of economic economic damages. However, it is, anyone could envision how a bad actor might be able to utilize cybersecurity vulnerabilities to cause something to happen that could result in harm. And so, in order to prevent that, we felt like we had to include that in this document. Now, I will
Yes,
say
and
we
it
didn't feel
it
like we,
makes sense,
yeah,
Carol, living in the world that we live in now,
yeah,
unfortunately.
unfortunately, we didn't feel like we had to completely reinvent the wheel because, the whole, the healthcare and the financial sectors have done a lot of work in decades in ensuring that their systems are cyber secure. So we can go to those and learn what they've done well and what works there. And so, we generally will tend to point to best practices in existing cybersecurity standards. But the fact is, we felt like we had to do that. We did have to point to those requirements in our safety standard.
In the press release that that announced the updated standard, the A3 president, Jeff Bernstein, he
Mhm.
says this updated standard is a call to action. How is
Mhm.
this a call to action, specifically for our audience of packaging production professionals who are using the industrial robots, as well as the packaging machinery manufacturers who are incorporating them into their systems?
Well, it's really a call to consider safety right from the start. So one of the things that in the safety community believes in our standards committee members who really devote hours and hours of their lives, days even, to uh, developing these standards and writing down the current best practices. They are incredibly devoted people to the safety of others, which is it's really inspiring to work with them. But one of the key philosophical tenets of standardization for safety is that we want to design it in right from the start. So we can't, safety isn't something you can think about after the fact. Safety isn't something you say, well, okay, I have this industrial robot system and we're about to turn it on. Quick, somebody make sure it's safe. That's not the right way to do it. So the the call to action is really to take a look at safety around your industrial robots. And before you even start talking to a supplier or an integrator who's going to design and build that industrial robot system for you, you need to be thinking about safety right from the start. You need to include things like do the risk assessment iteratively.
One last question, if I may. So I understand that there is a part 3 to the standard that you expect to publish a little bit later this year, and that is the safety requirements for users of industrial robot cells. Is
Mm-hmm.
there anything else that you can tell us about that's in the works?
Yeah, and actually that's something we're really excited about. So the part 3 is something that we haven't really had as a standard since the 99 edition of R1506. And the reason for this is because after the 99 edition, we decided we were going to do the work first in the international sphere. And so actually, ISO documents are not allowed to address requirements to the user. And the reason, there is a reason for that. And the reason is that each country and culture has different legal and regulatory environments for the requirements of safety. And in the US and Canada, in the US, I don't know, I'm talking about the US, but Canada is consistent with this. We we require that the employer create a safe work environment for their employees. That's how we do it in America. Other countries do it differently. So in Europe, again, they have the machinery directive, which says that a machinery manufacturer can't actually sell a machine until they have proven to the satisfaction of the machinery directive that their machine is safe. In the US, it's more the buyer needs to ensure that the thing they're buying is safe. So because of these legal and regulatory differences in the different countries around the world, the ISO approach has been let that happen in the local, regional, or national standards. And so what we've done with in the ANSI framework in the US is we've developed what we call Part 3. And the Part 3 content is going to state requirements for the users of robot systems and robot cells. You should be preparing training for your workers or updating the existing training for your workers. You should be instituting a system for managing change to the system, because what seems like an innocent change could actually affect the safety of that system. And so Part 3 is going to go into all of those things, like how do you, first of all, work with your integrator to make sure that what you've got is an acceptably safe system. And second of all, how do you manage that system throughout its life cycle to make sure that it stays acceptably safe for your workers. So we did try to give that guidance in the intervening years, but TRs are different than standards, and they can't contain requirements. And so now we're going to have a requirement, and it's going to say this shall be done, and so that's going to be in Part 3. And so we're really, really close to getting Part 3 published. I would say I'm hopeful that within the next month to 6 weeks.
Oh,
so we're actually
very close. Yes.
Yeah, very soon. And when Part 3 is ready, we're actually going to bundle it together with Parts 1 and 2. And so the whole package is how we're going to distribute it from A3's own web store.
And did I get this right, that if people do buy the standard now, Part 1 and 2, that they get number 3 for free when it comes out?
Yes.
Okay.
Yes.
Thank you.
Yeah, we're going to distribute that. So we're going to keep a record of who purchased Parts 1 and 2, and then send them Part 3 when it's available. And then, of course, after that date, when it becomes available, we'll just sell it as one thing.
Sure.
So, but we honestly think that our goal is to have that done before the International Robot Safety Conference, which this year is going to be the first week of November. So I am actually very confident that we'll be able to announce that at IRSC, if not before. Part 3.
Where is the conference this year?
It's in Houston.
Okay, great. Wonderful. Wow. Carol, thank you so much for giving so much detail about this new standard revision for robotics. As I had said a little bit earlier, there is a lot of automation in general for any kind of factory production these days seems to be, looking for some of the newer technologies to stay competitive for companies. And robotics, industrial robotics definitely is there at the high end of the technology to get them wherever they need to be as far as automation goes these days.
Yep.
Thanks for your time. Appreciate it.
Sure thing. Thanks again for the opportunity.
Good luck with Part 3. We'll keep an eye open for that.
Okay. Thank you.
Okay. Thanks.
Take care.